Hi guys, today we are going to talk about special right triangles, but before that we're going to review a little bit here about square roots. So remember your perfect squares, you need to know those. That'll come in handy with this stuff. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. Okay, so here's all your perfect squares. I think it goes down to 400 on here. Yeah, so it's your first 20 perfect squares. Okay, then we have this theorem that we talked about once before. It says that the square root of a times the square root of b is equal to the square root of a times b. So this would be something like the square root of 3 times the square root of 7 is the square root of 21. Okay. Now we need to talk about how to rationalize a fraction. So in general, we do not leave square roots in the denominator of a fraction. So the way we can get those off is we take this whatever square root's in the denominator, and we're going to multiply by that over itself. Okay, so of course this is 1, and when you multiply anything by 1, you do not change its value. So we will have something that looks different, but it has the same value. Okay, so here we go. We're going to go 10 times the square root of 2 is 10 square root of 2, and square root of 2 times square root of 2 is 2. And since 2 goes into 10 evenly, we can go ahead and change this to 5 square root of 2. And that is our rationalized answer. Okay. So on this one here, this has a square root of 3 in the denominator. We would multiply by square root of 3 over square root of 3. We would get 7 square root of 3 on the top, and we would get 3 on the bottom. And since I can't cancel 3 with 7, I'm just going to leave it like that. This is my exact answer. Now, it might be that you want to, you'd rather have a decimal approximation, in which case you can just do that on your calculator, 5 times the square root of 2 or 7 times the square root of 3 divided by 3, and get those values. Okay, but those are decimal approximations. Remember, the only way that you can write a number exactly if it's got a square root in it is to write it with the square root in it. Okay, so you've got how to rationalize a fraction there. All right, so let's talk about a couple of special right triangles. The first one is the 45, 45, 90 right triangle. Okay, so it looks like this. It's actually an isosceles triangle. Let's do this. So the reason it's special is because instead of needing 2 sides to find the third side, I only need to find one. I only need to know one side, and I can find the other 2 sides. Okay, so if I know this side here is x, I know that these 2 angles are equal, which means they're opposite sides. This side and this side are equal, so this is also x. And now what I can do is I can use the Pythagorean theorem to find this side. We'll temporarily call this y. Okay, and so I know that x squared plus x squared equals y squared. And I can go ahead and combine those. That's 2x squared equals y squared. And then I can square root this because I don't want to know what y squared is. I want to know what y is. So y is going to be the square root of 2 times x. Okay, and usually what we do, since the you can square root 2 and you can square root x squared. Square root 2 is just this. I can't reduce that. But a square root of x squared, I can just make plain old x. And we usually write the x out in front like this. So there's no confusion as to whether you mean this or you mean this. Okay? So the other thing you can do is you can kind of put a little deal like that right there to show that it ends at the square root of 2. Okay? So now I know that this side right here, that's going to be x square root of 2. So let's say I knew this side was 5. I would know this side is 5, and I would know this side is 5 times the square root of 2. If I knew this side was 7, this would be 7, and this would be 7 square root of 2. If I knew that this was 12 square root of 2, then I would know that this would be 12 and this would be 12. Okay? The only kind of tricky thing that comes in is when this side here is something other than something times the square root of 2. For example, what if this side is just 8? Well, okay. Remember, if this is x times the square root of 2. So if x times the square root of 2 is 8, then to find out what x is, I would divide by the square root of 2, like so. This would cancel out, and I would get x equals 8 over the square root of 2, which I would need to rationalize. That would be 8 square root of 2 over 2, which is just 4 square root of 2. So if this side was 8, this side would be 4 square root of 2, and this side would be 4 square root of 2. Okay. So there's your 45, 45, 90 right triangle. Let's look at the other one. The other one's the 30, 60, 90 right triangle. Okay, again, I only need to know one side of the triangle. Now what we're going to start with here is this side right here. This is the shortest side of the triangle. Now here's what you do. Is if that's a 60-degree angle, if I take this side right here and I reflect it over this line, I get a triangle like this where this is going to be x, this is going to be 90, this is going to be 60, this is going to be 30. Now, this is 60, 60, and 60. This is an equilateral triangle right here. And so all the sides are the same. So if this side is x, that makes this x. This whole side is 2x. That means this side is also 2x. Okay, now what I can do is I can kind of forget about this triangle right here. Okay, so I want to leave that there so that you've got it in your notes. But here's basically what happens. We've figured out that if this is x, this has to be 2x right here. Now I can use the Pythagorean theorem, and I can find y. So x squared plus y squared equals 2x squared. This right here, I square the 2, I square the x, and I get this, 4x squared. I'm going to go ahead and subtract x squared from both sides. And I'm going to get y squared equals 3x squared. And then I'm just going to square root both sides. And I'm going to get, here, let's put this here like this. All right, so remember the square root of x squared is just x, and the square root of 3 is just square root of 3. So I now know that this side right here is x times the square root of 3. So if I knew that this side was 5, this side would be 10, and this side would be 5 times the square root of 3. If this side was, say, 30, this side would be 15, this would be 15 times the square root of 3. If this was 8 times the square root of 3 on this side, then I would know this would be 8 and this would be 16. Again, the weird one is when this is something else other than something times the square root of 3. For example, let's say it was 10. So if this side was 10 right here, okay, I would need to divide by the square root of 3. So 10 divided by the square root of 3. Oh, I've got to rationalize that. So I multiply by this, I get 10 square root of 3 over 3. Okay, that'd be this side. And then this side would be 20 square root of 3 over 3. Okay? So, there's your two special right triangles, the 30, 60, 90 and the 45, 45, 90. Oh, what happened? All right, here we go. So we've got some here. So let's take a look at this first one. This is a 45, 45, 90. I always think it's a good idea to write down the ratios of the sides like this, which tells me that this side is 6, and this side is 6 times the square root of 2. And I'm done. Okay. Now, why don't you take a second and, well, let's do this one together first. Let's change up the colors here. Okay, so this one, this side's 5 square root of 2. So remember, this is x, and this is x square root of 2. So if this side is 5 square root of 2, that means this side must be 5, and this side also must be 5. And I'm done. Okay. Here's a couple other 45, 45, 90 right triangles. There's 4 of them, actually. So why don't you pause the video, give these a try, and then jump back on and see how you did. Okay. So now these were trickier ones than what I gave you before. Remember, you got to write down the sides: x square root, x square root of 2. Okay. So that tells me if this side's 7, that equals x times the square root of 2. I need to divide both sides by square root of 2. And I'm going to get this side is going to be 7 over the square root of 2, which I do not leave that way, so I rationalize it. So I'm going to multiply by square root of 2 over square root of 2, and that's going to be 7 square root of 2 over 2, which I cannot simplify. So that's my answer for that side. That's my answer for this side. Okay, now here's a weird one. We haven't really looked at one like this. This side is 6 square root of 5. I treat it the same way that I did before. I'm going to say, well, this is equal to x times the square root of 2. So I'm going to go ahead and divide both sides by square root of 2. This is going to cancel out. And I'm going to get this side right here is going to be 6 square root of 5 over square root of 2, but I have to rationalize it, so I'm going to multiply by square root of 2 over square root of 2. Well, let's see. This is going to be 6 square root of 10 over 2. The 2 will cancel with the 6 and make a 3 square root of 10. So this side is going to be 3 square root of 10. This side will also be 3 square root of 10. All right, moving down a little bit. Remember, the sides are x square root of 2. So this side should be easy enough. This is going to be 10 square root of 2. And then I'm going to use the Pythagorean theorem to find, well, this one's going to be, I don't have to use the Pythagorean theorem. That's the beauty of this. I'm going to take this side times the square root of 2. So 10 square root of 2 times square root of 2. Well, that's 10 times 2, which is 20. So this side here, the hypotenuse is going to be 20. Okay, over here, remember, this is x square root of 2. So this side should be easy enough to get. 25 times the square root of 7. Done with that side. This is going to be 25 square root of 7 times square root of 2, which is 25 times the square root of 14, which there's no perfect squares that go into 14, so I'm just done with that one. Okay, so there you should have got all those sides. All right, we're going to do the same thing with the 30, 60, 90 right triangles. Okay, so this one, remember, we write down the sides. This is going to be x, this is going to be 2x, and this is going to be x times the square root of 3. So this is an easy enough one. If that's 7, this is going to be 14. And this is going to be 7 times the square root of 3. And I'm done. Okay. So here's 3 more. Why don't you go ahead and pause the video and give those a try. And then we'll come back and see how you did. Okay. So 30, 60, 90, this is going to be x, this is going to be 2x, and this is going to be x square root of 3. So if that's 16, this is going to be half of that. It's going to be 8. This is going to be 8 square root of 3. And that one was super easy. Okay. Okay. Now let's look at this one here. Okay, again, this is x, this is 2x, and this is x square root of 3. So if x square root of 3 is 9 square root of 3, that means x must be 9. So this side is 9. This side is twice that. It's going to be 18. And you're done. Again, that's a super easy one. All right, now, don't be fooled here. People say, oh, this is 2 square root of 3. Okay, so this has got to be 2. Nope, wrong side. This is the short side. This is the side that's x. That means this is 2x, so it's going to be twice as much as this. It's going to be 4 square root of 3. That was easy enough to do. This is going to be x times the square root of 3 here, so it's going to be 2 square root of 3 times square root of 3. Well, square root of 3 times square root of 3 is 3, so this is going to be 2 times 3, which is 6. This side is 6 right here. Okay, here's a couple of more difficult ones for you. Why don't you pause the video again and give those a try, and then jump back on and see how your answers compare to mine. Okay, so let's do this. This is x, this is 2x, this is x squared root of 3. So x squared root of 3 is equal to 5, which means I'm going to divide by square root of 3 to figure out what x is. And I need to rationalize this. So this is going to be 5 square root of 3 over 3. That's going to be that side right there. And then this is just going to be twice as big, so it's going to be 10 square root of 3 over 3. That's pretty easy to do. Okay. Now remember, this is x, this is 2x, and this is x squared root of 3. So this is going to be, take this divided by 2, so this is going to be 5 square root of 7 over 2, which I can't really simplify, so I'm done with that side. And this is going to take this times the square root of 3, so 5 square root of 7 square root of 3 over 2 is just going to be 5 square root of 21 over 2. And I can't really simplify that because there's no perfect squares that go into 21. And so I'm done. Hopefully you got all those. All right. Here we've got let's say we got a box that's, say, 5 inches by 6 inches by 8 inches. What is the longest thing that we could put in the box? So what's the distance from this corner of the box to this corner of the box? Okay, well, this is very much like the Pythagorean theorem. Okay, so what we're going to do, we can do this in steps. If you get really confused, you can say, well, let's see. Here's a right triangle down here. Okay, so I would use the Pythagorean theorem, and I would say, well, that's going to be 6 squared plus 8 squared equals, we'll call this y squared. So y squared is going to be 36 plus 64, which of course is 100, and that means that y is 10. Okay, so I know this is 10. Now I've got a right triangle right here, okay, where I've got 2 legs that I know, so it's going to be 5 squared plus 10 squared equals x squared. So 25 plus 100 is x squared. So x squared is 125, and x is going to be the square root of 125. Now I can simplify that because I know that 25 goes into 125 5 times, so I can change it to that. And then the square root of 25 is 5. And that's going to be that distance right there. Okay, so I can just break that into two examples of the Pythagorean theorem because I have two right triangles involved. I've got one right here, and I've got another one right there. Okay, so you got a nice little lesson right here. I will talk to you guys in class. Have a great evening, huh?